In this video, I want to talk a little bit how the velocity CMOS detector works and how we can adjust it. So we've safely positioned the sample at 70 degrees tilt. We've inserted the detector, and we're getting a live image. And we can see here, this is our camera panel that we see on the camera tab in Apex. And it tells us here that we're getting an output of 2800 frames per second. This value here tells us an intensity maximum. So if we're fully saturated, this would be 1. So we're at about just a little over a quarter of the maximum intensity. Looking at this camera panel, I want to show a few different things, and we'll go over this. But first, we have the binning. This is the pixel resolution of the camera, and you can see we have a few different options that we'll play with. Typically, for most applications, we're going to be running at 4x4 binning. We'll talk about that a little bit more. We can control the exposure time. That's how long we dwell to collect a signal for each frame. I'm going to talk about the range here, but we'll see we have different ranges that essentially define the width of this exposure bar. And so we'll start with this small one here. Mode, this is where we want to try to go faster. So standard mode, we're using the full bit depth of the image. When we go to a high speed mode, we send lesser bits to get more data through the imaging pipeline. And the one I want to start with is image processing. So what I want to do here is I'm going to first start and show none. This shows just the live image coming from the camera. You can see here, it's also shown here in the what we call the raw or live pattern window here. And what I want to show is the relationship between exposure time, image brightness, and this maximum value. So you can see if I increase my exposure time, my image becomes brighter. This maximum value increases. You can see I've reached the maximum of this range. So at this point, I would make this larger, and I can slide up. And you can see when this essentially reaches 100%, it's rounding error, but we're now saturated. Doesn't matter how much more signal we put in, we're not going to go higher than that. So we obviously don't want to run saturated. We want to run below this, and we can run significantly below this. But what I want to show is what the pattern looks like with something, typically maybe 80%. And if I just put my beam and I click around, you can see we see the diffraction signal, and it's nice and bright and clear. The more electrons we collect, the better our signal-to-noise ratio. That's just counting statistics. But as we talk further about the system setup, what we'll find is we don't need the highest quality patterns in order to index. And the trade-off we have there, you can see that we're at 80% intensity, and we're getting, about 1,000 patterns per second. That's going to limit our speed. So if I bring this back down, and I'm going to go somewhere lower than this, and you can see the image starts to get darker. And I'm going to go maybe down to maybe 15% or so. And you can see we're up more at 4,400 frames per second. The image is dark, and if I put it into external mode, you can see we still see the pattern, though. There's still very much information there. And on my image processing, I can say, let's normalize this, so at least we can see it. So this is just stretching the image to see that, oh, yes, there is a usable diffraction signal even at this lower intensity. And I can even go this a little bit lower to get an idea of what happens. We can, so across this maximum exposure range, even at lower signals, we can get useful information. And so this will be important as we talk about, where do we want to operate for speed versus highest quality patterns and for different applications. But it's important to know that even at these lower exposure ranges, we can typically get some pretty good EBSD patterns. Now, I've put normalize here. We still see that this live image is a regular exposure. Now, I'm going to go somewhere just a little bit in the middle, maybe somewhere where we started out, 2,000 to 3,000 points per second, just to have something sort of mid-range in terms of intensity. Because what I want to show is we've seen how exposure time can adjust the intensity and also the speed. The other things we're going to see are the effect of binning. So I'm going to switch here to 1x1 binning, and it's going to switch the mode. So while it does that, I'm going to pause for a second. So it takes a couple of seconds for it to change camera modes to go to this 1x1 binning, but now you see we're running at a higher pixel resolution. And so our frame rate actually has not changed. but the image itself has more pixels. We're now at 640 by 480 pixels. Sometimes when people want to collect the highest pixel resolution image for something like cross correlation, this is the mode that will be used. But for typical EBSD mapping applications, again, we're going to use the 4x4 binning. But I just want you to see that, yeah, we get patterns at this higher pixel resolution as well. The thing to be aware of is that even though we're getting a higher frame rate, we're not going to be able to process these as fast because there are essentially 16 or 4x4 times more pixels being sent through the data pipeline. So the bandwidth to transfer this data is less. So we don't get the highest scanning speeds at the smaller binning settings, which is typically why we would do 4x4. So I'm going to go ahead and switch back. And so now we're back to 4x4 mode. For these first three, 1x1, 2x2, 4x4, those are distinct modes in the camera. 8x8 and 16x16 are just software settings. And you can see that when they do these, we're getting a summation of the data. So our intensity level changes a little bit between these. These do also, you'll see there's no speed increase as we go to these higher binning. And that's different than older traditional CCD cameras. The reason people would choose to do these is that if you're going to save pattern files, these pattern files will be smaller. Pattern files can get large, but still, generally, I would recommend operating and saving at 4x4 binning. And that's just an idea of how changing the exposure time, changing the binning affects the final patterns. But again, I would recommend running at 4x4 binning, and in a subsequent video, we're going to talk about the background subtraction, and we'll talk a little bit about optimization.